I have quadrant 1 completely blank, so let's just kind of talk about how we can fill this in. Because moving forward, I've said to you all in this class, more than likely, and I don't know for sure yet, so I'll come back and give you an answer on this, but I'm not going to have you memorize it, okay? Most of the time, if we're taking assessments, I'll provide the unit circle for you. At least that's kind of my impression as of now, okay? But that might change. But we do want to work towards kind of seeing patterns and ways to generate this, to where if it's not provided, how can we make it so that we're taking an assessment, we can have this somewhere on our test, okay? So quadrant 1 is kind of the key to that. So I start with just down here at positive x, where we haven't done any rotation, that's 0 degrees, and also 0 radians. I know at my positive y, that's 90 degrees, right? That's a right angle, which is pi over 2 rotation. Okay. Also at those axes points, the coordinates are a little easy because they're just the radius, so 1, 0, and 0, 1. And then to fill in all of these increments, I remember that they are increments of 30, 45, and 60 in between the axes. So this is 30 degrees, 45 degrees, and then 60 degrees. And so to make the conversion from degree to radians, I'm not going to just convert each of these. Kind of like what I explained yesterday, I use this negative x, which I know is not in quadrant 1, but I use the fact that that half rotation is equal to pi. And then I can just think about these degrees, how much rotation to get to pi, which is essentially how we convert degrees to radians anyways, right? That's essentially the same process. We're just able to get more of a visual this way. So I'm like, okay, 30 goes into 180 6 times, making this radian pi over 6. 45 goes into 184 times, making it pi over 4. And then 60 goes into 183 times, making it pi over 3. Okay, and there's all of our radians and degrees. So now for the coordinates, I remember there's 3 coordinates in between the axes. Those being root 3 over 2, root 2 over 2, and 1/2. Now to me, these aren't hard to remember. The denominators are always 2. The numerators go 1, 2, and 3. And in fact, we could square root all the numerators, right? We could call them all root 1, root 2, root 3. Because what is the square root of 1? It's just 1. So that's still equal to 1/2, okay, after I simplify it. So denominator is always 2. Numerators are 1, 2, and 3. And then they're all being square rooted. So now what I think about from here is which of these values is the largest, which one's in the middle, and which one's the smallest. Root 3 over 2 is definitely the largest value. Okay, they're all relatively close, but root 3 over 2 is the largest. Root 2 over 2 is the middle, 1/2 is the smallest. So then I'm like, okay, if I want to get to this point, how far over am I having to go? I'm having to go over by the largest amount, making that x value root 3 over 2. At pi over 4, I'm going over by the middle amount, so root 2 over 2. And at pi over 3, I'm going over by the least amount, which is 1/2. And then the y values are just going to be the opposite. So pi over 3 is the largest value, because that's the furthest up, so root 3 over 2. And then at pi over 6, the y value is 1/2. And there we go. Okay, there is our quadrant 1. Okay, so using this quadrant 1, if you have this memorized, and if you're always able on an assessment to make this somewhere, you can find trig functions of any angle from here. And that's going to be what I want to just touch on today. Okay, and it won't be much more than what we did last time. So let's just, real quick, for example, let's pretend we want to find tangents of 215 degrees. Okay, we'll work with the degrees here. So I first need to figure out where is that rotation? Where does 215 get me to? Now, I still need to kind of have an idea as on the axes, what are my kind of degrees and rotations there? So 180 negative x, 270 negative y. 215 is 45 more than 180, okay? And it's actually 45 less than 270, so it's right in the middle here. So I draw that angle, it gets me to a certain point. Then I know that this angle from the start, that's that 215 degrees. But here's how reference angles kind of factor into this. Okay, reference angles, and this was a brief thing that I mentioned in notes a couple days ago. The reference angle is however much rotation we have to the nearest x-axis. So our nearest x-axis here is at 180. And when I use that, I'm going to draw my triangle so that the vertical leg is perpendicular to that horizontal leg. And I'm going to use this angle here. Yeah, Jimmy, go ahead. Yes, thank you. Good call. Mary, is that what you're going to say too? Correcting my math there. Appreciate it. Okay. Yeah, otherwise you wouldn't have been on the unit circle at 215. So now at 225, again, using that reference angle, I'm like, how much rotation have I gone past this x-axis? So I've gone 180 to 225. That's 45 degrees more. So then I'm just using the coordinates at 45 degrees in quadrant 1. Those are going to be the same here. So root 2 over 2, root 2 over 2. But I know that in quadrant 3, x and y are both negative. So that's negative root 2 and negative root 2. So I'm just going to recreate this triangle away from my unit circle. Hypotenuse is always 1. The reference angle was 45 degrees, meaning my legs are root 2 over 2 and root 2 over 2. But in quadrant 3, since tangent's negative, both of these angles or both of these side lengths are also negative. So now I can do one of two things. Using this triangle, I can find tangent of 225, which is equal to tangent of 45, as long as we consider the signs. Okay, it's all going to be the same. Okay, that's the signs of these legs that matter. And so I can take the opposite over adjacent side here, which remember from yesterday, that vertical leg of your triangle is the y, the horizontal leg is the x. So this is also equal to the y coordinate divided by the x coordinate.
Please excuse interruption. Students, if you are going on the art field trip.
All right. So if I take y divided by x here, that's negative root 2 divided by 2 divided by another negative root 2 over 2. Anything divided by itself is 1. Just a second. There it goes. All right, so that's kind of how we use reference angles. Now, if you have the unit circle in front of you, obviously you don't need to do any of this work. Okay, but again, as you transition into pre-calc, and what I'm going to encourage you to do as you work through the homework is see if you can't find these values without your unit circle. And if you have quadrant 1, you're going to be able to do that. All right? Let's practice this again. I'm going to do another example similar to this, where we're going to act like we don't have the unit circle in front of us. So we're going to see if we can't kind of use quadrant 1 and reference angles to find values of all 6 trig functions with a corresponding central angle of 300 degrees. So with this, if I don't have my unit circle, I first am going to figure out where is 300 degrees at. So I have 0, 90, 180, 270, and 360. So 300 ends up being 30 degrees more than 270. So that's that rotation. And so then the reference angle, again, needs to be drawn to the nearest x-axis. So I'm going to draw that vertical leg so it's perpendicular to the x-axis. The reference angle here, I'm going from 360 down to my rotation, so 360 minus 300 is 60 degrees. So then I'm going to redraw this triangle, and I always draw it so that it's oriented into quadrant 1. That way I can use quadrant 1 to find the point and the side length. Okay, so here's where knowing quadrant 1 is really helpful. Like 60 degrees, that's this third kind of rotation in quadrant 1, where I know that the x coordinate is the shortest, 1/2. The y coordinate is the largest, root 3 over 2. Okay, so that's at 60 degrees. And those coordinates correspond to side lengths on this 60-degree triangle. The only thing we need to consider is here in quadrant 4, which of these side lengths might be negative. Well, in quadrant 4, the only thing that's negative is the y, so the vertical leg. So negative root 3 over 2. And now, if I want to find all my trig functions at 300 degrees, I can use that triangle, which we generated by using reference angles. So sine of 300, I'm going to use the fact that sine is opposite over hypotenuse. But remember from our conversation from yesterday, the opposite side is equal to the y-coordinate on the unit circle. The adjacent side is x, and the hypotenuse is always 1. So this ends up being y over 1, which is just y. So it's just negative root 3 over 2. Okay, so there's a few ways of how you can kind of actually come up with this value here. Cosine of 300 being the adjacent side over the hypotenuse, so that's 1/2 over 1, which is just 1/2, or just the x-coordinate. Tangent of 300 is the opposite, so y divided by the adjacent x, so either opposite over adjacent or y over x. We're going to have to do some simplifying here as we have negative root 3 divided by 2 divided by 1 divided by 1/2. Lots of divided bys there. So negative root 3 over 2 times the reciprocal of 2 over 1, which is negative root 3. Now the other three functions are the reciprocal functions. So cosecant of 300. I can take the reciprocal of this value, but I also want to kind of make the connection to what we had with the side lengths. Remember, with it being the reciprocal with side lengths of triangles is now equal to the hypotenuse over the opposite side, which is 1 over y in this case. So to find this value, I'm going to take 1 over negative root 3 over 2, which ends up being 2 over root 3 and negative. And I need to get rid of that square root in the denominator by multiplying by root 3 over root 3. So it's negative 2 root 3 over 3. Then secant of 300 is 1 over x, or I can just take the reciprocal of what I got for cosine, reciprocal of 1/2. It's just 2. And then cotangent of 300. In this case, I'm going to use the reciprocal of negative root 3 rather than doing this x over y or adjacent over hypotenuse, because that's just going to save me a little bit of simplifying. So negative root 3, the reciprocal of that is 1 over negative root 3. And I need to multiply by root 3 over root 3. So we get negative root 3 over 3. So this is kind of the process for if you want to kind of push yourself and not just look at your unit circle. This is how you would go about doing that, right? When you're doing the homework, I don't really care how you do it. If you're like, I'm still getting the hang of this, use your unit circle. But if you have it down, try to do it without your unit circle there. All right, any questions here before I'm going to have you all do 2 kind of quick things, and then we'll get you going on your unit circle. Or on your homework, excuse me. All good? Okay. So kind of like how we ended yesterday, I'm going to give you some trig functions at given rotations that are on your unit circle. And I want you to try to use this without your unit circle, okay? Just for in class today. And then again, when you do your assignment, you can do it whatever way kind of works best for you. All right. So I'm going to have us let's just do 2 of these. Let's have us do G and then also J. Don't worry about H, I, K, or L. Okay, so you're going to do G and J and try to do this without a unit circle. With J, think about what negative rotation means, okay, because that's a little bit different than all the work we've done thus far. All right, give you a few minutes to do that. The easiest way to come up with these values would, of course, to be use that unit circle, figure out where your rotation is, and then either use a triangle, so you're thinking about SOHCAHTOA, or if we remember that sign as Y, makes it even a little bit quicker and easier from there. Okay, but without the unit circle, I got to figure out where's my rotation. So this brings me into quadrant 3, and I'm recognizing that I'm pi over 6 more than pi. So I've rotated pi over 6 past this negative x-axis. That's my reference angle, the pi over 6. So I'm then going to kind of make my triangle. I will always orient it so it's in quadrant 1. And I know that at pi over 6, okay, that's that shortest angle or shortest rotation, the first one in quadrant 1, where the x is the largest value, so root 3 over 2, and the y is the smallest. With us being in quadrant 3, both those coordinates are negative though. Sine, being the opposite over the hypotenuse, is just negative 1/2, which is equal to the y coordinate there. All right, questions there? Okay, part J, and this brings up kind of an important thing to remember about negative rotations, because we haven't dealt with negative rotations since we kind of first were drawing angles. Remember, the negative rotation means we're going to rotate clockwise. Your unit circle is not written in negative rotations, right? Your unit circle has all positive rotations. So you have to really think about where are these going to take me, okay? And that's going to be important on your assignment too. And I'm going to kind of share one thing about that assignment here in a second. So tangent of negative pi over 2, well, I know that pi over 2 is a quarter rotation, okay? When it's positive, bring me up to positive y. But with it being negative, now I'm going to rotate clockwise, bringing my rotation down to the negative y-axis, where those coordinates are 0, negative 1. Now, I can still draw my impossible triangle there, right? That's very impossible because one side length is 0. And when I do this, the one thing that I kind of have to remember for it is the x-coordinate is my horizontal leg, the y-coordinate is that vertical leg. Then I can find tangent by taking the opposite, so negative 1, over the adjacent, which is 0. That is also equal to us taking y divided by x. Okay, and when we divide by 0, that is undefined. All right, so you got to be really careful with that. Some people are wanting to call that 0. Okay, questions here before I just say one last thing about negative angles. Okay, so on your homework assignment, number 1 is cosine of negative 5 pi over 4. And so if you're using the unit circle, you're not just going to simply rotate to 5 pi over 4. That positive 5 pi over 4 would put you into quadrant 3. But remember, this negative angle means that I need to rotate a clockwise direction. So I can still use the positive rotation and figure out, okay, where does that bring me to? 5 pi over 4 is about a pi rotation, an extra fourth. So I'm going to do that same thing just in the opposite direction. So that actually brings me into quadrant 2. So negative 5 pi over 4 is going to correspond to some positive rotation on your unit circle. And if you look at where that ends up bringing you to, the positive angle for this would be 3 pi over 4. Now, another way that you can come up with that, and one thing that we learned back when we first were drawing angles, is something called a coterminal angle, where we have some rotation, but it's equal to another value that has an extra revolution added to it. So what we did for that is if I had negative 5 pi over 4 and I want the coterminal angle, we add rotations to it. So if I add 2 pi, well, that's 8 pi over 4. Negative 5 pi plus 8 pi is 3 pi over 4. Okay, so that's another way of how I can come up with that angle and then use the unit circle from there. Yeah. There's lots of ways of how you can kind of figure out where that should bring you to. Okay,